Hello, parents. Thanks for joining me on this episode of the Fast Math Freebies at Home Edition. Do you have a third, fourth, or fifth grader, live in the state of Florida, and want to help your child prepare for the Fast Math assessment in May? Well, if you're answering yes to all three of those questions, you are in the right place. My name is Miss McCarthy, and I am a former Florida public school teacher on a mission to make math fun, make it click, and make it stick. For years, I've been creating resources with teachers in mind, and now I'm expanding my impact to create affordable and engaging math video lessons and practice for you to use at home with your child. The following free episode is actually a part of a free course, so all you have to do is click the link in the description box, enroll in the course today, and you'll have access to all of the Fast Math freebies, the video lessons, and the printables for this grade. And now it's time to dive into that free episode, so let's do it. What's going on, fifth grade? Here is your problem this week, so go ahead and pause the video and try this one on your own first. Then when you're ready to continue, press play. And oh, by the way, you might need a square corner and scratch piece of paper for this one, because that's what we'll be using when we go over it, okay? All right, I'll see you soon. Welcome back, fifth grade. Let's go over this one. So this says select all of the triangles that can be classified as obtuse and as an obtuse isosceles triangle. So it needs to be obtuse and it needs to be isosceles. So I'm going to go ahead and jot down some notes here that an obtuse triangle, we need one obtuse angle. And isosceles means that we need how many sides to be equal or the same? Yeah, two sides the same, that's isosceles. Okay, two sides that are equal in length or the same size. By the way, I'm gonna go ahead and link a geometry song that I have for this to help you remember what does obtuse mean, what's isosceles, and all about triangles. So I'll include that just in case you need a review. All right, so let's go over this. The way that I'm gonna tackle this is to look for the obtuse angle first. So we're gonna look at each one of these they're not rectangles. We're going to look at each one of these triangles and we're going to try to see if we can identify an obtuse angle. So an obtuse angle is wider than a right angle. So if we have a square corner and we measure it up, we line up our angles and it looks wider, we've got an obtuse angle. The way that I'm filming this, I cannot get a piece of paper, but I'm going to mimic what it would look like with a piece of paper. So here I go with a red piece of paper, but you can use any square corner as long as it's a perfect square corner on a sheet of paper. So looking here, I can tell that for the very first one, okay, I can tell that this angle is acute, and I can tell that that angle is acute, but I'm not sure about the top angle. So what I'm going to do is take my square corner, and I'm going to tilt it and try to put it right where this angle, line it up perfectly. Oh my goodness, this looks just like a right. You can see that my square corner lines up perfectly with that corner up top. So this is not an obtuse angle. What kind of angle is it? It's right. Yes, this is a right angle. So therefore, we can go ahead and eliminate this one because we don't see an obtuse angle. I do believe that this is isosceles though, which means that those two sides are the same. But because I've already identified there is no obtuse angle, we can move on. Now this one right here, look at this skinny angle, that's acute. This one is acute, and I can tell for sure, I can tell that this one right here is obtuse. So I'm just going to line it up with one of the rays of that angle the best that I can. All right, that's about as good as I can get it. And there you can see that this other side goes out wider than a right there. So that is obtuse. So I'm going to come back to this one and check to see if it's isosceles in just a minute. Moving on to that third triangle, I can tell that this side is acute, this side is acute. If you needed to try to get your square corner in there, you would see that it goes behind it. And this one down here, it looks obtuse, but let's just check to make sure. Try my best to line this up right here. That's about as good as I can get it. And we can see that the other side extends past that right corner. So we know that this is obtuse right here. But looking at it, I am seeing different looking sides, but I'll come back to that because I did identify one obtuse angle. All right, coming over here, these 3 angles are acute, so we can eliminate that one. For this one, this would be an acute angle and this would be an acute angle. And what kind of angle is up here? Yeah, it's an obtuse angle. If you want to pause the video to try to put your square corner in there, go ahead. And then over here, we know that this is acute, and the top one is obtuse as well. So let's go back to the ones that have the question marks and identify which ones are isosceles. So the way that I would do that, it's going to be a little different to show on a device, but I will do the best I can. So if I were using a piece of scratch paper, I would take that scratch paper, put one corner at the start, and then mark the length of that side. Then I would turn that paper to the other one to see if it was the same length. And if you notice for this one, it is the same length. So because those are 2 sides the same, and then this one over here would definitely be longer. See, this one goes way longer. So we have 2 sides the same. That means that this one contains an obtuse angle and isosceles because there are 2 sides the same. So we can mark that one. I'm going to take to measure some of these sides. So let me get the measure of the first side. My tool was being a little fussy with this one. So I'm going to let you know that these 3 sides, they actually are all 3 different sides. So this would be a scalene triangle. It would be obtuse. Let me put this up here. So this would be obtuse and isosceles for that one that we just did. This one is obtuse, but it's scalene because we have 3 different sides. Again, you could use your paper to measure it and then just line up that paper along the angles. For the other question mark, we do have an obtuse angle. And if you were to measure all the side lengths, you would see that we have, again, 3 different side lengths. So that would be obtuse, scalene. And this final one, these 2 sides are the same size. You can take your paper and measure it, your scratch paper, and then this one would be the side that is not the same. So this would be obtuse and isosceles. So it would be those 2 answers right there. And then just for kicks, let me go ahead and put that this one would be a right isosceles triangle. This would be an acute equilateral triangle. We have 3 acute angles and we have 3 equal sides, equilateral. So again, your paper, your square corners are a gem here. Definitely use those to your advantage. You can just put it up on your screen and just start measuring it around. That's totally fine when you're taking the fast math test. So that's how you do this one. Go ahead and pause the video if you need to jot down any notes. And again, if you need a review on obtuse, acute, right, scalene, equilateral, isosceles, all of those terminology, all that vocabulary, check out the geometry vocabulary video that I've linked below. Thank you so much for joining me today. And remember, if you're looking for the principle that goes along with this video, you can enroll in that free course today, which gives you access to this video and the printable and all the other videos that I've created, the Fast Math freebie episodes, all in one place for you. And you know what? If you're anything like me, it's out of sight, out of mind. I know that you're busy, so why don't you go ahead and do that now? That way it's off your plate, you take care of it, and you can get your instant access today. Thanks again, and I cannot wait to see you inside the free course.